again. This is the second of 3 demonstration videos for the rock cycle. So if you're watching this and you have not yet seen the first one and finished parts A, B, and C, I suggest you stop where you are right now, go back and find the first one and watch that one first. This one will help you answer the questions in part D, which deals with metamorphic rock. So what we have here is the wax sedimentary rock that we formed last time. It almost looks like a pizza in the video, but it is pink, not tomato sauce. What we're going to do now is we're going to demonstrate how you would take a sedimentary rock and conform it into metamorphic rock. So we're going to be looking now at how we form something like this rock sample, which is called gneiss, Gneiss. And one thing that I'll point out about this one is that if you look at it closely, and I realize it's hard for you to do that, but I can kind of bring it a little closer maybe and see if we can keep it in focus. You can see that there are still kind of distinct bands in it. You know, it's a little like sandstone still, but yet the texture of it's very different. It's much harder. It does feel rough, but it doesn't fall apart. So this is a much tougher and stronger rock because it has been through some things. Okay, this has been through a lot of heat and pressure to get like this. So metamorphic rocks are rocks that really form, pretty deep down in the bedrock. They have to be at a point where they're getting a lot of heat and a lot of pressure, but they're not melting. So that's kind of key. I mean, they are changing, but they're not melting. So we're going to sort of simulate that here. I have a bowl of water. This water was boiling a little bit ago. Now it's about 150 degrees. As you can see, this is my little candy thermometer here. So I'm going to take that out. And we're going to take our sedimentary rock here, and it's still, you remember the layers and all that. We're just going to tuck it in here, and we're going to keep it in the bag so that it doesn't go everywhere. And this is one of those where in the classroom this would take a while. What I'm going to do for you right now is I'm going to pause this video. So for you, it'll just magically happen in a matter of seconds. But we're just going to let the heat kind of act on this. And it probably will have some predictable results, but I'll show you what happens in just a minute. All right, so we're back. Again, I know for you that it was just a second, but I actually have left this in here warming for a little while now. So now we're going to go ahead and take it out, and we're going to see how it looks. The water is quite a bit cooler now, so it's not quite so hot to handle. Oof. Okay, so as you can see, our sedimentary rock is still kind of evident here. You can still see like the flecks of white. Of course, the pink is now much more evident because it's had a much, I think just a much more potent color. So that really kind of came out. Ugh. And of course, it's changed shape some because I tried to adapt to the size of the bag, which isn't inappropriate because metamorphic rock does the same thing. When it goes through pressure and heat like that, it will fold and form into different shapes and sizes. So you can see now we have a completely different shape, but you can still see some pretty distinct features that are left over from whatever rock it was before. In our case, it was a sedimentary rock, so you can see that there's still, some layering in there. It's not pronounced, but it also doesn't fall apart quite the way the other one did. Like it is kind of falling apart because it came apart in small pieces here, but individual pieces are not just flaking off really easily now because the metamorphosis that it went through, being exposed to heat like that, has kind of fused it together better. Okay, so that's very similar to our gneiss here. And again, that's Gneiss, not, it's nice anyway. This is nice. And notice that it is, like the sandstone, it has a layer to it, but the layers are much more solid. Like I can't flake anything off of this one like I could off the sandstone. So we're gonna take a chunk of this and kind of put it here alongside our metamorphic rock. And we're going to now, use this to answer the questions under part D. Okay, so under number 7, step 7, it's going to ask you to draw a sketch of it. And again, use the tools and step scopes, do the best you can. You don't have to label anything, but just kind of make it, look kind of swirly like this one does. And then it says, compare your rock with a sample of metamorphic rock and record your comparisons. So again, this one is our example. I have already done now a microscope video of this, so you can see it up close and kind of get a sense of it. But you can kind of take a look at this. Again, you want to kind of compare this and just notice again, you can see some features, not very many. But when it comes to comparing and contrasting these, and how much time it probably took to make this versus how much time it took to make that, notice that in this case you can definitely see some sort of distinct crystals, where in this case it's a little more smooshy. But also do notice that it still kind of holds some of the resemblance to the sandstone that's crumbling on here, without looking exactly like it anymore. It has obviously changed. Um, Number 11 then asks, what is the energy source in this model? So in our model, of course, the heat that changed that rock came from my hot water. Okay, so this is where that energy came from, that changed that wax from being little tiny flakes of wax into more of a blob of wax. So that's definitely what you want to think about there. But in number 12, it's asking about the energy source involved in the formation of metamorphic rock. So again, now metamorphic rock typically forms pretty deep in the Earth's crust. So not all the way down into the mantle, like it doesn't melt all the way, but it's deep enough that that mantle is really what's causing a lot of the heat, and all the rock above it is what's putting it under so much pressure. So when it comes to the energy source, think about that. It's also because it's under the ground, the sun can't get there, so that kind of narrows it down. And number 13, in terms of stability and change, what change occurs in the system during the process of metamorphic rock formation? So you might recall the change that we had for sedimentary rock was that we had a big rock and we broke it and it went into small pieces, right? In this case, we have a piece of rock and we're applying heat and pressure to it to create a change. Okay, so that's what you want to kind of describe for number 13. All right, talk about what this kind of did. And the actual mechanics of doing this to a rock is not that much different than doing it to wax. It does melt it just a little bit and kind of make it glom on in a different way. Does the rock that forms, this is number 14, does the rock that forms into a metamorphic rock undergo a chemical or physical change? Now, obviously, wax is still wax, but there is, in this case, when between this rock and the sandstone, has undergone a complete change. If you were to analyze the minerals that make up gneiss as compared to sandstone, they are quite a bit different. Okay, so think about that as you answer that. How do we determine whether it's a physical or chemical change? And then use that to decide what your answer is for number 14. Okay. I think that brings us to the end of part E. And I'll just check my text before I let you go. Okay. Now, process E will be in the third video. So please go ahead and pause now. I would finish up all of the questions for process D and then look for video 3 so that you can do process E. All right, good luck.